Hello everyone, let's discuss a question that is based on the calculation of delta G mixing and delta S mixing for an ideal solution. The question is, an ideal solution is made from 5 mole of benzene and 3.25 mole of toluene. So this is an ideal solution and we know that ideal solution follows the Raoult's law. Calculate delta G mixing and delta S mixing at 298 Kelvin and 1 bar pressure. Okay, is mixing a spontaneous process? So we have to calculate delta G mixing and delta S mixings. What are the component of this solution? So basically we have two component. We have toluene, and we have benzene. These are the two component of this ideal solution. Toluene mole is 3.25 mole, and mole of benzene is 5 mole. Okay, now first we have to calculate the delta G mixing. Okay, delta G mixing is given by this expression: delta G mix equal to nRT xt ln xt, that is the mole fraction of toluene, plus xb ln xb. Okay, that is the mole fraction of benzene. So we need to calculate first the mole fraction. Mole fraction of toluene will be equal to mole of toluene by mole of toluene plus mole of benzene, and that will be equal to 3.25 divided by 3.25 plus 5, and if we do it, we'll be getting around 0.394. Similarly, mole fraction of benzene will be just mole of benzene divided by mole of benzene plus mole of toluene, and that is equal to 0.606. You can also find mole fraction of benzene simply by subtracting the mole fraction of toluene from 1, because sum of the mole fraction, that is xt plus xb, must be equal to 1, because this is a binary solution, so mole fraction summation will be equal to 1. Okay, now we have to put all the values, okay, in this. So this n is the total moles of the solution. So n is how much? 5 plus 3.25, that is 8.25 into r. R is the universal gas constant, and in joule per mole per Kelvin this value is 8.314 joule per mole per Kelvin. Okay, into temperature must be in Kelvin, that is 298, so we have to put the value 298, into mole fraction of toluene, that is 0.394 ln 0.394, plus mole fraction of benzene, that is 0.6, okay, 06 ln 0.606. Okay, now we have to simply use the scientific calculator to calculate that, and you will be getting around minus 13.7 into 10⁻³ joule. So this is the value of delta G mixing. Now next we have to find delta S mixing. So delta S mix is given by this expression. It is minus nr x ln xf plus xb ln xb when the component is x, a and b, but here it is toluene and benzene, so it will be xt ln xt plus xb ln xb. Okay, yeah. Now we have to put the value here. Again the total mole is 8.25, so I will put 8.25 into r, that is universal gas constant, that is 8.314. Okay, xt, mole fraction of toluene is 0.606 ln 0.606 plus, sorry, this is of benzene. Toluene is how much? 0.394. So 0.394 ln 0.394 plus 0.606 ln 0.606. And we have to simply find this by using scientific calculator, and we will be getting around 46 joule per Kelvin. So that is the value of delta S mix. Now next is this mixing a spontaneous process? Is this mixing a spontaneous process. So you know that for a spontaneous process, what we need delta G should be less than 0. So if delta G mix is less than 0, and it is very clear here, we are getting this delta G mix, that is minus 13.7 to 10 to 3 joule. That is a negative value. Okay, so this is a spontaneous, or mixing is a spontaneous. Okay, if the two liquids, you keep that in mind, that if the two liquids are miscible in each other, if the two liquid are miscible, completely soluble in each other, then delta G mix will always be less than 0. Means it's you know mixing will be always a spontaneous process, and delta S mix will be always greater than 0. Okay, so that's all. Thank you.